Hello all, in today's class we'll discuss about kinematics of cam. So basically cam is rotating element which we are using in with help of follower we are using in IC engine mechanism to open and close the inlet wall and outlet wall. So basically we have different types of cams, like we have rotary cam, spherical cams, okay, then we have elliptical cam, okay, and to operate that particular cam we are using different types of follower, flat face follower, roller follower, then we have knife edge follower to operate that inlet and outlet wall with the help of this cam and follower arrangement. So this is the components of cam and follower. So just look at the arrangement. This is a spherical cam with the help of follower. Okay. And by providing different uh, angle of rise, dwell and return, we can operate this cam and follower mechanism. So basically in cam angle of rise, the wall lift will start. During dwell, we can insert film in the combustion chamber, and during return, the wall closing will start. So these are the three angles which we are using in this cam and follower arrangement. Okay. Now, this is the arrangement of cam and follower mechanism. Now, if you look at the basic working principle in IC engine mechanism, this system is connected to camshaft. That cam is connected to camshaft. Then we have this follower arrangement, and that follower is connected to that inlet and outlet wall arrangement. So this is the link which we are connecting to the inlet and outlet wall with the help of this cam and follower mechanism. Okay. Now, what we have different types of cam. We have rotating cam. Under rotating, we have translating follower. With the help of rotating cam, we can use oscillating follower. Again, in translating cam, we are using translating follower. So these are the some examples where we are achieving that motion transmissions with the help of these combinations of cam and follower mechanism. Okay. Now just look at the arrangement. We have this knife edge follower, spherical follower. Okay. This is the knife edge follower arrangement. Then we have a roller follower arrangement. Okay. For smooth transmission, mostly people are using this roller follower arrangement. That knife edge follower in knife edge follower arrangement, there is a lot of wear and tear is available. That's why people are going with roller follower. Then we have tangential follower, which is also known as a flat face follower, and we have spherical follower for smooth transmission of opening and closing of wall. We are using these arrangements. Okay. Now, based on the type of contact in mechanism, we are using this part. So what we have, according to the surface in contact, we can use a knife edge follower. Okay. Suppose say in knife edge follower, we are so suppose if we have smooth, suppose if we have instant motion transmission. For instant motion transmission, we can use this knife edge follower arrangement. Okay. Then next, for smooth motion transmissions, we can use this roller follower arrangement like in engine, normalized engine mechanism in aircraft engine. People are using this roller follower arrangement where we are having rolling motion between cam and follower. Okay. Then we have flat face follower. In flat face follower, again, we are achieving the movement. Okay. So then the wear and tear is less and motion transmission is very smooth in case of flat face follower. And in spherical follower, okay, so to minimize the stresses, surface stresses between the contact between cam and follower, we can use spherical face follower. So these are the basic arrangement of follower, cam and follower, cam with knife edge follower, cam with roller follower, cam with flat face follower, cam with spherical follower, and cam with offset follower. So these are some examples where we are achieving the motion transmission between these various combinations of cam and follower. Okay. Now next part is suppose say if you want to achieve motion transmission with the help of different offset or radial movement. Again, we have these combinations. Suppose if that follower is mount on axial in axial direction with respect to cam, then that is radial follower. If it is offset by some distance towards right and left with reference to the axis of cam, then it is called as offset follower. Okay. Now again, we have different types of cams, like radial cam is available. Okay. So this radial cam operates in we can say oscillate in direction perpendicular to the cam axis. The cam has shown in radial follower like this. This is the different arrangement of radial cam follower. Okay. So all these followers are radial follower, where axis of that follower is passing through the axis of cam. Okay. So this combination is known as radial follower. If axis of that follower is coupled by some distance, that offset distance, then this follower is known as offset follower. Okay. Then we have next combination, cylindrical cam. So basically in cylindrical cam, that follower operates in parallel direction to the cam axis. Okay. So it has some groove slots where that follower is operating and we can achieve the motion transmission. Okay. Now first we need to understand the different terminology which we are using to define this cam profile. So first part is base circle. Okay. So this is a base circle which is known as the smallest circle of that cam. Okay. And which is used to draw the cam profile. Then we have trace point. Okay. Now next part is this trace point. Trace point is nothing but a reference point of the follower that is used to generate the pitch curve. In case of knife edge follower, the trace point and the pitch curve of the different both are same. In case of roller follower, center of roller will represent the trace point. Okay, so this is the center of follower, roller follower, which is representing the trace point. Okay, then next we have pressure angle. Okay, now what is the pressure angle? It is the angle between the direction of follower motion and normal to the pitch core. Okay, that angle is a pressure angle. This angle is very important. If it is too much large, then we can say that the reciprocating follower will jam in its bearing. Okay, so to avoid this, there is a angle of pressure angle value for this cam profile is around 21 degree to 25 degree. Okay, then we have pitch point. So it is the point on the pitch curve that is having maximum pressure angle. Pitch circle is nothing but it is a circle. We have this. This is the pitch point. Then we have pitch circle. Okay, so this pitch circle, this is a circle drawn from center of cam that is passing through pitch point. All these pitch point, that circle is known as pitch circle. Then we have pitch curve. Okay, so it is the curve generated by this curve is known as pitch curve. It is the curve generated by the trace point of the follower as the follower moves to relative cam. So for knife edge follower, the pitch curve and cam profile are same, whereas roller follower, they are separated by radius of roller. So whatever the radius of roller is available, center point of the circle which is passing through center point of that roller, all the center point of the roller, that circle is known as pitch curve. Okay, in case of roller follower. Then we have prime circle. So it is the smallest circle that can be drawn from the center of cam and tangent to the pitch curve. Okay, so for knife edge and flat face follower, the prime circle and base circle are same. Okay. Then next is lip top stroke. This distance is known as lip top stroke. Lip or you can say stroke. It is the maximum travel of follower from lowest position to the topmost position. That distance is known as the lip top follower. Okay. So this is all about the terminology of follower. So we are using different types of follower. Okay. In day-to-day applications, where we are finding the as per the applications, we are selecting the appropriate types. Okay. And based on that, we can generate the this cam and follower regime. So basically, in case of cam and follower, what we have base circle. Okay. Then we have roller circle for that cam profile. And then we have third circle. That circle is known as a prime circle, pitch circle. Okay, which is passing through that particular maximum pressure angle point. And one more point we have pitch curve, that is the curve which is passing through the center point of all these roller positions. That curve is known as a pitch curve. Okay, and we have this pitch point. So the pitch point is nothing but it is the point where we are defining the orientation of that particular curve with respect to the values in a displacement diagram. All the points which we are tracing. Okay, so all the points which we are tracing with the help of this pressure angle values of that particular follower movement. Okay, so when we have maximum pressure angle value, then that point is known as a pitch point. Okay, so this is all about the basic terminology which we need to know while plotting that cam and follower. Okay, so we'll stop here. In next class, we'll discuss different types of follower motions.